Hello everyone, welcome to Victory Pure English batch for class 11th JEE and NEET. This is me Arvind Suthar and I welcome you all in this session on permutations and combinations. So today in this session we will be covering this topic entirely, and I have observed that kids do face a lot of problems in this particular topic, right? Because what happens is they don't know when to apply the formulas. So I'll give you some amazing examples today so that you can clearly master this topic. So without wasting much time, I'm taking you over there. First we're going to discuss about factorial. Factorial of natural number n is nothing but the product of first n natural numbers. That means if I talk about 5 factorial, it is nothing but 5 into 4 into 3 into 2 into 1. Similarly, if I talk about 3 factorial, then it is nothing but 3 into 2 into 1. Similarly, if I talk about 2 factorial, it is nothing but 2 into 1. If I talk about 1 factorial, then it is nothing but 1. If I talk about 4 factorial, it is nothing but 4 into 3 into 2 into 1. If I talk about 5 factorial, it will be 5 into 4 into 3 into 2 into 1. If I talk about 6 factorial, it will be 6 into 5 into 4 into 3 into 2 into 1. Yes or no? You must remember a few of the values from here. That is 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120 and 6 factorial is 720 and so on. You can write down all the factorials. Right? Okay, number 1. If I am talking about n factorial, then n factorial is what? N into n minus 1 into n minus 2 into n minus 3 into n minus 4 and so on till 3 into 2 into 1. Yes or no? Important results that you must remember over here is 0 factorial is nothing but equal to 1. Factorial of negative integers are not defined as of now in your JEE syllabus, and n factorial is nothing but this. A very important thing, n factorial is equals to n into n minus 1 factorial. Let's look at that. If I talk about 1 factorial, it is nothing but 1. If I talk about 2 factorial, it will be nothing but 1 into 2. If I talk about 3 factorial, it will be 1 into 2 into 3 as I told you already. Okay. 4 factorial will be nothing but 1 into 2 into 3 into 4. Yes or no? And so on. If you move ahead, you can write down all the formulas as we have just discussed. Yes? Okay. If somebody comes and tells me, sir, this is nothing but 4 factorial, so I would like to write down this thing as 4 factorial times of 5. Can I do that? Yes, obviously, because 5 factorial is nothing but 1 into 2 into 3 into 4. If somebody comes and tells me, sir, I would like to write down this thing as 3 factorial times of 4 into 5. Yes, that is absolutely right. Yes, everyone? Okay. A lot of guys do commit one mistake, and that is what? If I give them anything like this, they write it like this. Is it true or false? Everyone, do let me know. Is it true or false? This is false. This is false. You cannot take factorials common like this. Over here, this is 2 into 6. That is 12, whereas if you see over here, it will become 6 factorial. 6 factorial was 720, right? You cannot take common like this. Okay. A lot of times kids do make mistake like this, 2 factorial plus 3 factorial. If I ask them, they write it like this. They say, sir, factorial we have taken common. You cannot do that. This is nothing but 2 plus 6, that is 8. And this is 5 factorial. 5 factorial is 120. So this is also wrong. Okay. So do remember these kind of things. Okay. And the very important property that I just talked about, that n factorial can also be written as n into n minus 1 ka factorial. N into n minus 1 ka factorial. This can be written. So this is a very important thing. Do remember this. Do remember this. Factorial will be used very extensively in this particular lecture. Okay, fundamental principle of counting. Now, understand this fundamental principle of multiplication. There are 2 rules basically. One is addition rule and another one is subtraction rule. Multiplication rule. Addition rule and multiplication rule. Multiplication rule. These rules are quite easy, but you just need to understand when to apply these rules. Let me tell you an example. If I give you, let's say, 2 t-shirts and 3 shirts, and I give you a condition that if you are wearing a shirt, then you cannot wear a t-shirt, and if you are wearing a t-shirt, you cannot wear a shirt. That means out of these two, you have to do only one thing. That means either you wear a shirt or you wear a t-shirt. So there is something called choice. If you are wearing a t-shirt, that is also fine. If you are wearing a shirt, that is also fine. So that is a choice. If you want to wear a shirt, you can wear a shirt. If you want to wear a t-shirt, you can wear a t-shirt. So there is a sense of choice, or in Hindi we can use the word ya. Ya means we have a choice. The Hindi wala word ya, that means a choice. So whenever this kind of a choice is there, we do add the things. Okay, let's say these two t-shirts are t-shirt 1 and t-shirt 2. That is t-shirts of let's say black color and white color. Okay, and let's say that the three shirts are shirt 1, shirt 2, shirt 3. Let's say one shirt is black, one shirt is blue, one shirt is yellow. Okay, so in how many ways you can wear anything on top? This will be done by using addition rule, that is 2 plus 3 ways, that is equal to 5 ways. How this has come? Look. How many ways you can wear a t-shirt? Either you can wear this t-shirt or you can wear this t-shirt. So this is one choice, this is another. So these are the two things written. How many ways you can wear a shirt? Either shirt 1, shirt 2 or shirt 3. So these are the three choices. And since either I wear a t-shirt or I wear a shirt, anything is fine by me. So I am having a choice either to wear a shirt or to wear a t-shirt. So there is also a sense of choice, or there is a sense of ya, Hindi wala ya. That's why I am adding down the things. So in total we can get dressed on top in 5 ways. Whereas if you look at the another example, let's say I am having 3 t-shirts and I am having 2 pants, let's say. Okay, now if you have to get dressed over here, you have to wear a t-shirt as well as a pant. You have to wear both. You cannot wear a t-shirt and can go outside, right? Definitely you need to wear both. If you wear a t-shirt only and you don't wear a pant, you will be, people will be calling you PK. If you are wearing a pant and you are not wearing a t-shirt, then in that case, people may feel like as if you are behaving like Salman Khan. So that cannot be the case, right? So what am I trying to tell you over here is, you have to do both the conditions. You have to do both the things over here. So there is a sense of condition. That means you have to do this as well as this. There is no choice. You have been given a condition that you have to do this as well as this. That means you have to do both. So we can say that there is a sense of and. And means whenever and comes, before the and, whatever is written or whatever is said, that also needs to be there, and after the end, whatever is written, that also needs to be done. Okay, that means I will say I wear a t-shirt and pant. I will never say I wear a t-shirt or pant. Or means if I am wearing any one thing, that is also fine. But I hope you understand that you will say in English that I wear a t-shirt and pant, not I wear a t-shirt or pant. So there is a sense of and. And says that whatever is written before and, that also needs to be done, and whatever is written after the and, that also needs to be done. So over here we can see that both of these things are needed to be done. Okay, so in that case, let's say we are having 3 shirts. So in how many ways we can wear a t-shirt? 3 ways. And in how many ways we can wear a pant? 2 ways, either this pant or this pant. So here, since we have to do both of these tasks, that's why we're going to multiply. So here, the ways of getting dressed are going to be 6. I hope this example perfectly solves all of your problem. So whenever there is a sense of choice, or there is a sense of ya in Hindi or in English, we're gonna add, and if there is a sense of and or a condition imposed on us, that is you have to do this task as well as this task, then there you're gonna multiply. I hope you guys are clear with this. Let's say I have been, now in the problems it will not be given to you that apply addition rule and find out the number of ways, or it will not be given to you that apply multiplication rule and find out the number of the ways. It will not be given to you. So rather you will have to figure out which rule you need to apply in the problem solving. Let's say I am here at this place A, and then I am moving to place B, and these are the ways. This is roadway 1, this is roadway 2, this is another way which is let's say train, and this is another way, let's say AR1. These are the 4 ways. In how many ways you can reach from A to B? 4 ways. Okay. And let's say there is one more destination over here, and I am telling you that in order to move from B to C, this is one roadway, R-1. This is one train way, T-1. This is another train route over here, and let's say this is A-1, another airway. Okay. In how many ways you can move from B to C if I ask you? So again you can say that, let's say one more way is there. In how many ways you can move from B to C? 5 ways. Yes or no? In how many ways you can move from B to C? In 5 ways. In how many ways you can move from A to B? You can move in 4 ways. Now, if I ask you one problem over here, that in how many ways, understand the question. Permutations and combinations is more about English. Okay, so understand the English, what am I telling you over here. If you have to move from A to C via B, in how many ways you can do that? A to C via B. This is number of the ways when you are moving from A to B, and this is number of the ways when you are moving from B to C. And now this time I am asking you, if you have to move from A to C via B, how many ways are there? Now look, if you have to move from A to C via B, that means what? You have to do this journey A to B, as well as you have to do this journey B to C. Yes or no? Everyone, do let me know. We have seen that in how many ways we can move from A to B? These are 4 ways. And in how many ways we can move from B to C? 5 ways. So if you have to do both of these tasks, so is it a condition or a choice? It is a condition, right? So in how many ways you can move from A to C via B is 4 times 5 ways. That is nothing but equal to 20 ways. What are these 20 ways? Once if you take road number 1 from here, then from here you can take any of the 5. So road 1, R-1, road 1, T-1, road 1, T-2, road 1, A-1, road 1, A-2. So these are the 5 ways. Road 2, R-1, road 2, T-1, road 2, T-2, road 2, A-1, road 2, A-2. These are the 5 ways, 10 ways so far. Train 1, road R-1, train 1, T-1, train 1, T-2, train 1, A-1, train 1, A-2. These are 5 ways, 15 so far, and similarly 5 from here. Air 1, road -1, air 1, T-1, air 1, T-2, air 1, A-1, air 1, A-2. Right. So these are total ways which you have just got. I hope you guys are clear with this. All right. Moving on to the next thing. If I ask you, let's say this is a mall. This is a mall. Now asking you 2 different problems. That's why I told you permutations and combinations is more about how the problem is given to you. Let's say this is a mall and these are the 3 gates. Why I am marking these gates like this is because you can enter and exit. You can enter and exit from the same gate as well. Okay. If I ask you a problem like this, in how many ways you can enter and exit from the mall? You can enter first and then exit from the mall. Understand the question? I am saying you that in how many ways you can enter and then exit from the mall. That means you have to enter as well as exit. In how many ways you can enter the mall? Sir, 3 ways. Either this or this or this. Okay, then in how many ways you can exit the mall? Another 3 ways. Yes, you have to do both of these tasks. That's why you need to multiply. So over here, you gonna have 9 ways of entering and exiting the mall. I hope you understood this. Okay, talking about the next problem. Let's say this is mall and these are the gates given to you. Yahan pe the condition was enter and exit from the same gate, was allowed. Same gate was allowed. Okay. Alright. Over here I am putting a condition that enter and exit from the same gate is not allowed. Same gate is not allowed. Over here, if I am saying that this is gate 1, this is gate 2 and this is gate 3, then here if I am entering through gate 1, then I can exit from there as well. in this case. Whereas over here, if this is gate 1 and I am entering inside the mall, from here I cannot exit from this gate 1. This is the condition I am giving to you. That's why I have said enter and exit from the same gate is not allowed. Okay. Alright. So in how many ways I can enter? I can enter in 3 ways. Okay, let's say I have entered through gate 2. Now I cannot come out through the gate number 2. Yes or no? In that case, how many gates are there for me to exit? I cannot exit through this gate, so only 2 gates are left out. So that is 2 ways of exiting the mall now. So in that case, in how many ways I can enter and exit from the mall such that enter and exit from the same gate is not allowed? So this is going to be the answer, because I have to do both. I have to enter as well as exit, but this time not from the same gate. That's why 1 way is reduced. So these are total 6 ways. Understood everyone? Anyone is having any difficulty? Yes? Okay. Moving on to the next thing. Now the same problem can be asked in words as well. The same problem can be asked in words as well. Let's say I have been given a word, these 4 letters GATE, and I have to form 4 letter words. Let's say I have been given these 4 letters and I have to form a 4 letter words. So I have to fill the positions, yes or no? Let's say these are the 4 positions which I need to form. You can see that if these are the 4 letters, then you can form words like this. I'm not saying that the words and so on. I'm not saying that the word should have a meaning. I'm only saying you that these are the 4 letters and how many words you guys can form by using these 4 letters. So in order to solve those variety of questions, what we do is we apply multiplication rule. Now why we why we use a multiplication rule is because, understand, this place can be filled in 4 ways. Why 4 ways? Because we can either fill G, A, T or E, anything. Okay, alright. Now once we have filled G over here, we are left out with only 3 choices for this place, either A, either T or E. Yes or no? Okay. Now let's say I have filled T over here. So for this particular place, we will be left out with only 2 choices, either T or either E. Let's say we have put E over here. So for this place, we are left out with only 1 choice, that is T. Yes or no? Everyone, do let me know. So in how many ways these places can be filled? Now understand, if you have to form a 4 letter word, that means you have to fill this place, this place, this place as well as this place. Then only 4 letter word will be formed. Yes or no? So all of these ways you need to multiply or add. Try to understand. Multiply. Yes or no? So 4 into 3 into 2 into 1 is nothing but number of 4 lettered words. I hope you understood this particular thing. Okay, over here repetition was not allowed. Repetition was not allowed. Repetition not allowed. That means what? You cannot fill G twice. You cannot fill A twice or more than that. You have been given only 1 A or only 1 G, only 1 T, only 1 E. In case the repetition is allowed, in case the repetition is allowed, repetition is allowed. Let's say you are given G, A, T, E and you have to form 4 letter word. So in that case, if repetition is allowed, then this place can be filled in 4 ways, G, A, T, E. Anything you have filled, it does not matter because repetition is allowed. So this place can also be filled in 4 ways, this place can also be filled in 4 ways, this can also be filled in 4 ways. So over here 4 into 4 into 4 into 4, you will multiply. Why? Because you have to fill each and every place, then only 4 letter word is going to form. So this many words can be formed. Over here words like G, 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 T, T, E, like this are also included. I hope you understood this particular thing, everyone. Now these problems can be there in numbers as well. These kind of problems can be there in numbers as well. Let's say I have given you digits like 1, 2, 3 and I have asked you how many 3 letter words you guys can form. So over here, in order to fill this place, we have 3 choices. If I am saying that repetition is not allowed, so this place can be filled in 2 ways, either by 2 or 1. Let's say 1 I have filled over here, so over here we are left out with only 1 choice. only one choice 2, yes or no? So over here we can say that 1 into 2 into 3 number of ways, so that is 6 numbers can be formed. Over here I am saying that repetition is not allowed. Repetition is not allowed. I hope you people understood this particular thing. If I am saying that you have been given these digits and repetition is allowed, then you guys can do one thing over here, and that is what? That anything can come over here, 1 into 1, 2 or 3, anything can come over here, yes or no? So this place can be filled in how many ways, kids? 3. Similarly, this place can be filled in how many ways? 3. This place can be filled in how many ways? 3. So 3 into 3 into 3. These are the total numbers formed. Yes or no? Everyone do let me know. If I ask you a question like this, I have given you 1, 2 and 3 digits. 3 digits I have given you, 1, 2 and 3. How many 3-digit numbers you can form? Understand. This repetition is allowed and repetition is not allowed sometimes is not given to you in the problem. You have to understand it and feel it on your own. Let's say I give you an example like this, that you have been given digits like 1, 2, 3. 1, 2, 3. These are the 3 digits you are given. How many 3-digit numbers you guys can form? If I ask you only this much, how many 3-digit numbers you guys can form? Now tell me, is 133 a 3-digit number? Yes sir. So by default, don't you think that if I say how many 3-digit numbers you can form, by default the repetition of the digits is allowed, because 133 is again a 3-digit number, 212 is again a 3-digit number, 222 is again a 3-digit number, yes or no? So by default, you have to understand that in numbers, repetition is allowed. So that's why you have to consider repetition of the digits is allowed in that particular case. Okay, all right. Moving on to the next thing, talking about the terms permutations and combinations. Let's first deal with combinations. And then we're going to talk about permutations. Okay, let's first talk about combinations. Now, combinations means selection. Combination means what? Combination means selection. And permutations means arrangement. Now, what is the difference between these two things? Whenever we select or we choose, order does not matter. Order does not matter. What is the meaning of this thing? Order does not matter. Which thing we are taking first, which thing we are taking second, it does not matter. Whereas in the case of arrangement, order does matter. Order does matter. Arranging itself is a sequence which is needed to be followed. That means an order has to be maintained. Arrangement itself means an order or sequence has to be maintained. Whereas choosing and selection, order does not matter. Like, let's say you have been given 15 member squad. Let's say as of now you are Virat Kohli or you are Rohit Sharma, and selectors have provided you 15 members list, and you have to select your playing 11, or you have to look for 11 people who will be playing in your game. So in that case, will you be selecting or arranging those people? I think you will be selecting only. So that is a problem of selection. Selection means choosing. So out of 11 people you can choose any, out of 15 people you can choose any 11, right? Okay. Whereas arrangement, the word order. Now let's say you have chosen those 11 people and you are sending them to bat. There is the term coming batting order. So their order will matter. That who is coming at 1 down, who is coming at 2 down, who is coming at 3 down, yes or no? So arrangement and selection are two different things. In arrangement, order does matter. In selection, order does not matter. Now, I hope you know that NCR, C stands for combination. So NCR is applied in the case of combinations, and permutations, in the case of permutations, NPR is applied. But my question is, every time, if every time the question is of selection, can you apply NCR? No. If every time the question is of permutations, can you apply NPR? No. There are certain cases in which, there are certain cases of combinations in which only you can apply NCR, and there are only certain cases of permutations in which you can apply NPR, not in every arrangement. Sir, what are those cases? Let me tell you about that. Okay, let's first deal with combinations. Let's first deal with combinations. Now, understand, there are three kind of categories which can be formed in the problem. One is distinct, another one is identical, and another one is few alike. Alike means same. Alike means same. Okay, alike, few alike and few distinct. Okay, these are the three category of problems. If all the things are distinct, then only you can apply NCR. You cannot apply NCR as number of the ways of selecting things. You can apply NCR only in the case when things are distinct given to you. Here you cannot apply NCR. I'll tell you examples. Here also cannot apply NCR directly. I'll talk about this. Let's first talk about this one. Okay. Whenever the objects are given distinct to you, let's say I have been given that 10 people out of 10 people select any 2. In how many ways you can do that? Now we know that people are distinct. Yes or no? We know that each and everybody is distinct. Distinct means different, unique. Yes? Different, unique, yes. So out of 10 people select any 2. So here the objects are distinct, so you can apply the formula. In how many ways you can select 2 people out of 10? NCR, that is 10C2. Here it is correct. But if I give you, let's say 10 identical oranges, how many ways of selecting 2? A lot of guys do what? Here also they apply the formula. 10C2, and let me tell you guys, this is wrong. And here also, if I give you such kind of a thing, okay, let's say I give you A, B, C. These 10 things I have given you, and I told you, and I asked you, select any 2. You cannot apply select any 2. You cannot apply 10C2 over here as well. The number of the ways of selecting 2 things out of these 10 available things is not 10C2, because these objects are not all distinct. Whenever the objects are all distinct, then only you can apply the formula NCR. I hope you understood this much as of now. Okay, so let me summarize what we have learned so far. That if point 1, if objects are given distinct, if R objects are to be selected, selected means combination, yes, out of n distinct, understand, 2 keywords are there, one is selection and another one is distinct. If out of n distinct objects, R objects are to be selected, then that can be done in NCR number of ways. I hope you people understood this. This NCR number of ways will come only in the picture when you have to select R objects out of n distinct things, right? Okay, let's say I have given you A, B, C, D. Select any 2 letters out of the 4 available. So we know that all the objects are distinct, yes or no? So in how many ways that can be done? 4C2 number of ways. Understood this everyone? Anyone is having any difficulty in this? Do let me know. Not an issue. Alright, moving on to the second point. If I give you anything like that, total number of ways of selection, total number of ways of selection, total number of ways of selection out of n distinct objects, then that can be done in how many ways? Do let me know. Now over here three words are very important. One is total, another one is n distinct, and another one is this selection. Look, over here total was not there. Over here it was given to me that select R objects out of the n distinct ones. And here it is given to me that total number of ways of selection. Here the quantity is not specified. So sometimes the problem can be like this. So in that case, if the quantity is not provided to you how many people or how many things you have to select, then in that case, what you guys can do, you can select any one, that is also fine. So that can be done in NC0 ways. If you select 1, that is also fine. So that can be done in this many ways. If you select 2, that is also fine. That can be done in this many ways. Select 3, that is also fine, and so on. You can select all of them as well. Yes or no? Because since over here it is not specified how many people you need to select. Now either I will be selecting 0 number of people, or I will be selecting 1 number of people, or I will be selecting 2 number of people, or I will be selecting 3 number of people, and so on. So there is a sense of or. Whenever there is a sense of or in mathematics, we do add the things. Yes or no? Yes sir. So this is nothing but equal to 2 to the power n, because I hope you have studied about this in binomial theorem, that NC0 plus NC1 plus NC2 plus NC3 till NCn is nothing but equal to 2 to the power n. So these are two different problems. Understand, number one, selection we guys are doing. We can apply the formula NCR only in the case when the distinct objects are given to you. So let's say if R objects are needed to be selected from n distinct objects, then that can be done in NCR ways. There is another kind of a problem in which total number of the ways of selection of n distinct objects, out of n distinct objects, total number of the ways of selection are needed to be find out. Then there, the quantity is not specified that how many objects you need to select. So over here if we are selecting 0 people, that is also fine, 1 people, that is also fine, 2 people, that is also fine, 3 people, that is also fine, till all the people are fine. So from binomial theorem we can get the answer of this particular thing as 2 to the power n. So either we say that total number of ways of selections are 2 to the power n, or we say that total number of the ways of selection are NC0 plus NC1 plus NC2 plus NC3 till NCn. Both are correct. I hope you people understood this particular thing. Anyone is having any difficulty in this? I don't think there has to be any. Alright, moving on to the next thing. Okay, point number 3. There can be things like this as well. Select at least, this word is very important. Select at least one object out of n distinct objects available. Okay, at least means the minimum condition that you have to do. At least means in Hindi we say come. You cannot select less than this. At least you have to select at least one, means the least to least. If you go, you have to do this. Without doing this you cannot proceed. Okay, now let's say if this kind of a thing is given, then over here you have to select at least one object, means you cannot select what? You cannot select 0 people. That means if you select 1, that is fine. If you select 2, that is fine. If you select 3, that is fine. If you select all of them, that is also fine. But you cannot select 0 people, because minimum to minimum you have to select at least one object. So either you will be doing this or this or this or this or this and so on. So ultimately you're going to add all these or not, because you have a sense of or. So this is nothing but 2 to the power n minus NC0. Yes or no, everyone, do let me know. So that can be done in how many ways? 2 to the power n minus NC0. If I ask you in the problem like this, point 4, let's say, select at least 2 objects out of n distinct objects available. Now here what you're gonna do, at least 2 people you have to select, means if you are selecting 2, that is also fine. If you are selecting 3, that is also fine. If you are selecting 4, that is also fine, and so on till all of them. Okay, so summation of all this has to be your answer. Now what is the summation? In binomial theorem you might have studied this, that 2 to the power n minus nc0 minus nc1 we need to do. Basically from this equation if you take these two things then you will get the sum of the remaining things, yes or no, and that is what the summation is, right? So understand, NCR can only be applied in the cases whenever the n distinct objects are given to you. People are already distinct, so there if it is not mentioned that people are distinct, then also you will assume them to be distinct only, because people can never be identical. Yes, okay. There is another case in which the objects are not specified, that how many people you need to select, but here it is mentioned total number of the ways of selection. So over here zero selection is also fine, 1, 2, 3, anything is fine. The third category is whenever the word at least is introduced. At least in Hindi means kam se kam. Minimum that you have to do is this much. So over here if at least one object is asked, then you cannot select 0 objects. So ultimately out of the total base 2 to the power n, you need to remove these number of cases, nc0. And over here if at least 2 objects are asked, you can remove both of these. If at least 3 people are asked, then you will remove nc2 from here as well. I hope you people understood this particular thing. Okay. Talking about the identical things, okay, talking about the second scenario, that is when the identical objects are given to you. Identical means look alike, look alike, look alike. In Hindi we say ek jaise. In Hindi we do call these people as ek jaise. So for example, oranges are identical. Okay, if you want to remember this particular case, then we can remember the meme Yogi Adityanath ji and Vin Diesel. Right? These two people look alike. So identical cases, in the case of identical objects, the selection is going to be from a different thing, not from NCR. How are we going to talk about that? Let me tell you. 10 identical oranges are provided to you. Objects are provided, or let's say 10 identical oranges are provided. 0 orange needed to be selected. 0 orange selected. In how many ways you can do that? There is only one way. If I am asking you 1 orange is selected, in how many ways you can do that? Not 10C1, only 1. If I say 2 oranges are selected, in how many ways you can do that? Not 10C2, it is 1. If I say 3 oranges are selected, in how many ways you can do that? Only one way. I hope you understood this. That for any quantity we will have only one way in the case of identical objects selection. I hope you people understood this. Selection of out of identical objects. Since these people are all same, these objects are all same, so it does not matter if you are selecting 0 oranges, that can also be done in one way. If you are selecting 1 orange, that can also be done in one way. If you are selecting 2 oranges, that can also be done in one way. If you are selecting 3 oranges, that can also be done in one way. Here the answer will not be 10C0. Here the answer will not be 10C1. Here the answer will not be 10C2. Here the answer will not be 10C3. I hope you people understood this particular thing. Alright, okay, talking about the next thing. This is point number 6, point number 5. Okay, let me talk about point number 6. Total number of ways of selection. Total number of ways of selection out of n identical objects. Identical objects. Then over here, understand, the quantity which you have to select is not specified. So 0 objects is also fine. 1 object is also fine. 2 objects is also fine. 3 objects is also fine, and so on. All objects are all fine, right? So from here you can say in how many ways I can select 0 object if an identical objects are given to me, one way. How many ways you can select 1 object? One way. In how many ways you can select 2 objects, identical objects? 1, 1, 1, 1, 1 every time. So you're gonna add all these ways to get your answer, because either you will be selecting one zero thing or one thing or two thing or three thing and so on all, right? So if n identical objects are given to you, then the answer is going to be n plus 1. N plus 1, because 0 objects, there is one way for 0 objects as well. Look, 1 object 1, 2 object 1, 3 object 1, like this till n objects you are going to get 1 1 1 1 1. But for this 0 object also you will be getting 1. That's why the answer is n plus 1 ways. If I ask you total number of ways of selection out of 10 identical oranges, then that will be nothing but 11. Then that will be nothing but 11. I hope you people understood this. Okay, talking about point number 7. Point number 7. Number of ways of selection of at least 3 objects out of n identical objects is. Can you tell me the answer? At least 3, I have used at least 3. So that means 3 object is fine, 4 object is fine, 5 objects is fine, and so on till all objects are fine. Yes or no? Okay. So 1 1 1 is the way for each and everything. Now understand, what we cannot do is, we cannot select 2 objects, we cannot select 1 object, we cannot select 0 object. So ultimately from n plus 1 we need to remove these 3 cases. So ultimately what is going to be our answer? N plus 1 minus these 3. So 1 plus 1 plus 1 we need to remove for each and every case. So it is going to be n plus 1 minus 3, that is equals to n minus 2 number of ways. N minus 2 number of ways. I hope you people understood this. Point number 7. If at least 4 is asked, then you cannot take this particular thing as well. I hope we guys are clear with this particular thing. Okay, moving on to the next thing. I hope you understood this much, right? Because people don't understand these things, that's why they are not able to apply these kind of things in the problem solving. So that is where the problem starts. Okay, yeah. Now there are certain cases. Point 8. Out of n distinct objects, p particular objects are never included. Number of ways of selection. Number of ways of selection will be how much in this particular case? These kind of problems also do come. So how to remember this category is, let's say Virat and Gambhir. Remember this example. Once they were playing during an IPL match and they fought among with one another. What happened? Let's say coach came and coach told that you people are India's national players, and you people were fighting in the middle of the ground. So from the next match, I'll not be letting you guys play. Okay, so let's say this has happened. So now the team will be having total 15 members. Out of these 2 P particular objects are never included. That means coach said that you guys will not be playing in the game. So these 2 guys are gone away. Now out of the total 15, these 2 guys are removed. They will not be there in my playing 11. So how many people are left? 13. From those 13 people only I need to select my playing 11, yes or no? So out of those 13 people I need to select my playing 11, yes or no? So this many number of the ways of team selection will be there in that case. Yes or no, do let me know. Because since coach told that Gambhir and Virat will not be playing in the game, in the next game, because they fight with each another. So he told that you guys will not be playing. So out of the remaining 13 people, 11 are to be selected for your playing 11? Yes or no? Because in a team announced by the selectors, there are 15 players. Out of those 15, you can select, in the normal scenario, what would have happened? You can select any 11 like this. But since coach has clearly specified that Virat and Gambhir will not be playing in the next game, so you need to select those 11 players from the remaining 13 only. So this many total number of ways of team selections will be there. In the case coach told that Virat and Gambhir have fought one another, so they will not be playing in the next game. That means if P particular objects are never together, then the number of the ways of selection will be what? N minus P C R. Okay, where R is number of the people needed to be selected, N is the total number of people available, and P are the number of the people who have been banned or have been told not to select them. Okay, this N minus P is together. I hope you people understood this. Now sometimes what can happen is point number 9. Out of n distinct, wait a minute, okay. Wait. Yep, okay. So out of n distinct objects, if I have been told that P particular objects are always to be included. Particular objects are always to be included. That means what? I'll talk about this. Let's say coach is highly impressed of Rohit, Virat and Bumrah. Or we can say, let's say Rohit, Pandya and Bumrah. So coach told that these 3 people have to be there in our playing 11. Out of n distinct objects, let's say 15-member squad was given, and out of them we have to select our playing 11. Coach told that Rohit, Pandya and Bumrah has to play because coach is highly impressed of their performance. Okay. So these 3 has to be there. That means what? There is no other choice. We have to take Rohit. There is no other choice. We have to take Pandya. There is no other choice. We have to take Bumrah. Right? If we are forming an 11-member team, then these 3 people has to be there. So in how many ways we can select Rohit? One way. In how many ways we can select Pandya? One way. In how many ways we can select Bumrah? One way. Out of the remaining people, how many people are remaining? 12. Yes or no? We have to select how many more people for our playing 11? 8. Yes or no? So in how many ways I can do that? 11C8. Yes or no, everyone? Do let me know. So what is exactly happening over here is, out of the total 15 members, these are the 3 people. So we are left out with 12 choices, and out of those 12 choices we need to select 8 people, that is 11 minus 3. Yes or no? So over here the formula is what? Over here the formula is N minus P C R minus P. These things are together and these things are together. I hope you understood this. Again, NCR is there, distinct is there, that's why we are using the formula NCR. Over here also the people were all distinct, that's why we have used the formula NCR. In the case of identical, we were not using the formula NCR. I hope you guys are clear with this particular problem. Everyone, are we guys fine with it? Yep, okay. Talking about the next point, and that is point number 10. Point number 10. Point number 10. Okay. Now what is this point? Let me tell you about this. Few objects alike. Okay, this is the case when few objects are alike and few are distinct. Few objects are alike, and few distinct. Okay, alike means same. Okay, now this is the case when, let's say, the objects are given to me like this. The objects are given to me like this, let's say A, B, C, D, D. These are the objects given to me. Now understand, not all are identical, neither all are distinct, nor all are identical. Neither all are distinct, nor all are identical. Yes or no? So this is the third case. Neither all the objects are distinct nor all are identical. Now in the case in these kind of cases, if selection is to be done, then we require case formation. We require what? We require case formation. If let's say I ask you that out of these people select any 3. Now you cannot do it like this. 1, 2, 3, 4, 5, 6, 7. Out of 7 select any 3. 7C3 is the base. Wrong. That will be wrong. Because you cannot apply NCR formula in the case when the objects are few distinct and few alike. Because we know that in the case of identical objects we cannot apply NCR. Over here few of the objects are identical, right? So we cannot apply this formula. So rather here what we do is we do case formation. Now what kind of a case formation is this, sir? Understand. The case formation means all objects, all 3 are distinct. Like in the case we need to select 3 things. So either we select all the 3 alphabets distinct, or we select 2 objects, 2 letters same, and 1 distinct, or we can select this all 3 letters same. Are you getting it? So this is the case formation which we have done. So all 3 are distinct. If you want to find out all 3 are distinct, in how many ways you can do that? Okay, how many choices we do have? If we are talking about all 3 distinct objects, then A, B, C, D. These are the 4 choices I am having since all the objects are distinct. So out of these 4 distinct, we need to select 3. So 4C3 is the number of the ways. Okay, over here if you see, 2 letters are same and 1 is distinct. 2 letters are same. Okay, understand over here? 2 letters are same. Let's first talk about this. 2 letters are same. In order to select this, A can be selected and B can be selected. We cannot select CC and we cannot select A is there and DD is there. We cannot select BB because no 2 B's are not there. We cannot select CC because 2 C's are not there. So understand, if 2 letters same needed to be selected, then there are only 2 choices, AA and DD. So out of these 2 pairs, take any one pair. Because the moment you take one pair, let's say you take this AA wala bundle, you have selected 2 identical things, yes or no? The moment you select DD, you have selected one of them in which two letters are same. So this is what we are selecting from the bundles. We have first formed the bundles of AA because 2 letters same are needed to be selected. So that's why the 2 bundles can be of AA and DD. There cannot be a bundle of BB and CC because B and C are only 1 in number available. Yes, okay. Then talking about this one distinct number, how can we get this? How can we get this particular thing is, let's say we have selected AA wala bundle over here. The moment we have selected AA wala bundle over here, then one distinct thing we need to select. So we cannot take A from the remaining these. We cannot take A because 2 letters are same and 1 distinct. So since we have taken, let's say, AA bundle, now the third thing we need to select is from B, C and D. So these are the 3 choices available. Out of these 3 choices, take any one. And talking about the third one, 3 letters are same. Now 3 letters are same means only A can be there because not 3 B's are there, not 3 C's are there, not even 3 D's are there. So only thing we can have is A. So the moment we select this 1C1, because we are selecting bundles from here. So there is only one bundle. Out of this one bundle we are selecting one bundle. So 1C1 is the number of the ways. So understand, these were the case formations, and now if we add these cases, we are going to get our answer. So the total number of the ways in which 3 objects can be selected from these available is 4C3 plus 2C1 into 3C1 plus 1C1. Here we have multiplied. Why we have multiplied here in the second case is because we needed to select 3 objects. 2 letters must be same. So we have taken any one bundle out of these 2. So 2C1. And then third letter was also needed to be selected. That's why, look, we have to select two things identical and one thing distinct. So we have to do both of these tasks. That's why we have multiplied in the middle case. I hope you are clear with this. So the total number of the ways are going to be 4C3 plus 2C1 into 3C1 plus 1C1. So this is how many, this is the number of the ways in which, these are the total number of the ways in which 3 objects can be selected out of these available. So in these kind of cases, we do apply case formation in order to select. I hope the things are clear to you guys. Yes? Alright, great. Yes, so far we have learnt about selections, and in selections we have seen 3 different categories: when the distinct objects are given to us, when the identical objects are given to us, and when neither identical nor distinct objects are given to us. So whenever distinct objects are given to us, what we do is we apply the formula NCR if we want to do the selection. In the case of identical objects, if we want to select, we cannot use NCR formula, and in the case of when the objects are not neither identical nor distinct, then we do case formation in order to select few things, right? Okay, so far we have learned combinations. Now it's time to go for permutations. So here we go, permutations. Permutations, as we have seen earlier, is arrangement, and arrangement involves order. Yes or no? Order does matter. Order does matter means which thing is coming first, which thing is coming later, it does matter. Let's say I have given you a few digits. Example, let's say I have given you a few digits. These are the digits I have given you. And if I ask you how many 3-digit numbers can be formed, 3-digit numbers can be formed. So there are numerous ways to solve these kind of problems. Let me tell you one particular thing. Now, a lot of guys are not able to understand that if these are the digits given to me and the question is asking how many 3-digit numbers can be formed. So, is it a problem of combination or is it a problem of permutation? Now, let me tell you one thing. If I take any 3 digits, let's say 2, 3, 4, and I form a number 2, 3, 4, or I can also form a number 4, 2, 3, or I can form a number 4, 3, 2. So don't you think that if I am having any 3 digits, let's say 2, 3, 4, and if I go on and form numbers, so there can be multiple numbers formed with the same digits, yes or no? So this problem will by default contain arrangement or not? Do let me know. Yes? So is this a problem of arrangement or not? Yes, absolutely. So let me tell you the method number 1 in order to proceed for solving such kind of problems is multiplication method. So multiplication method, we have seen that this place can be filled in how many ways? This place can be filled by either 3, 2, 3, 4 or 5. So this place can be filled in 4 ways. Let's say I am saying that repetition is not allowed. Repetition is not allowed. RNA is not ribonucleic acid. It is repetition not allowed. So in that case, if I have, let's say, filled 3 over here, then over here we can fill either 2, either 4 or 5. That is 3 ways of filling this particular place. Let's say I have filled 5 over here. Now this place can be filled by either 2 or 4. So this place can be filled in 2 ways. So how many numbers can be formed? Since we have to form 3-digit number, so each and every place is to be filled so that our 3-digit number will be formed. So here we are going to multiply all these 3 things and this many total 3-digit numbers will be formed. So 24 numbers will be formed if we are forming numbers by using these 4 digits. Yes or no? So what am I trying to tell you over here is multiplication rule. Multiplication rule by default involves arrangement. Right? So that is the answer of the particular problem, and let me tell you this very important concept over here, that multiplication rule by default involves arrangement over here. If you see numbers getting formed over here, the numbers will be like this. One will be 2, 3, 4. One will be 4, 3, 2. Like this. One will be 5, 3, 4, 5, 4, 3, 3, 4, 5. Like this. So how many total numbers will be formed like this? 24 3-digit numbers will be formed like this. I hope you understood this concept. So one way of understanding the arrangement is through multiplication rule. There we have seen the problems of going into the mall and exiting the mall. There also arrangement was there, entering, exiting. So two things were there, right? Once we can do the enter, then we can do the exit as well. So there also we were doing nothing but arrangement only. So multiplication rule by default involves arrangement. We should be absolutely clear with this particular thing. All right. Now in arrangement also, if you see, there are multiple cases. That is when the objects are identical, when the objects are distinct, when the objects are neither identical nor distinct. So distinct objects, identical objects, and neither distinct nor identical. Okay, yes, let's take these categories one by one. So first we're going to talk about this, then we're going to talk about this, then we're going to talk about this. So first let's deal with arrangement of distinct objects. Okay, now here this can be done by multiple ways. This can be done in three ways. This can again be done in three ways. Okay, there can be more ways as well, but I would like to discuss these three ways over here. Number one is multiplication rule. So the multiplication rule that we have seen already is used to arrange distinct objects. I'll talk about this more, though I have given you one example as well. Another thing is by using the formula NPR. P stands for permutation. If out of n different things you choose R and then you arrange R, it is nothing but NPR only. And the third thing is NCR into R factorial. NCR into R factorial. Okay. Yep. Let me tell you one formula over here, that NPR is again equal to NCR into R factorial only. Why I have talked about these as different ways is because over here combination and arrangement is included in one thing, and over here they are represented in different ways. Okay, I'll go ahead with this one by one. Okay, yep. Let's say you have been given example, let's say 10 people are there, and out of these 10 people, or let's say 15 people are there, or let's say 15 member squad is there, 15 member squad is there, and you have to choose your playing 11. In how many ways you can choose that? Since all the guys are going to be distinct, so this can be done, choosing means selection, so it can be done in 15C 11 ways. Okay, now if I ask you, in how many ways batting order can be done for 11 players? Out of 15. Now over here we have been given 15 member squad and we have to arrange or betting order, only 11 people will play from a single team, yes or no? So out of those 15 people, don't you think that you need to first select those 11 people who will be playing in your team? Okay, the moment you have these 11 people with you, now you have to assign them a proper place. So let me say that this is the first place. So over here 11 people can go because even Bumrah can open. Okay, this place can be built in 10 ways, then this place can be built in 9 ways, because if a person has already opened, then he cannot come at 1 down, 2 down, right? So that's why it is going to be like that. So there has to be 11 positions in terms of batting order. This is striker, this is non-striker. That's why they are also considered different. You can understand it like this. So if you do the multiplication rule over there, you can see that 11 factorial ways of arranging 11 people on 11 places, yes or no? So this is going to be your answer, and this can also be represented as 15PR or 15P11, because if you are having more number of people and you have limited number of seats, then for that you first select the people equivalent to the number of the seats that you are having and then arrange them onto those number of seats. I hope this is clear to all of you guys. Okay, let me tell you one thing over here, a very important note, that n people can be arranged on n places in n factorial ways. N factorial ways. Or we can also say it at npn, or we can also say it as ncn into n factorial or n factorial. They are all same because npn is nothing but equal to n factorial only. These are all same things. Let me tell you the formula as well in case I haven't told you so far. NCR is equal to n factorial upon r factorial times n minus r factorial. NPR is nothing but n factorial upon n minus r factorial, and NPR is equal to NCR into r factorial. These are the three formulas which are very important, and I hope each one of you already knows this formula. So if n people are needed to be arranged on n different places, then this can be done in n factorial number of ways. This is a very important result. Okay, the moment I have said people, or I can say over here n distinct objects. N distinct objects can be arranged on n places in how many ways, kids? They can be arranged in n factorial number of ways. I hope you guys are clear with this particular thing. Okay, let me talk about the next problem. Identical objects arrangement. Let's say I have been given A, and I have been given these two places, and there we have to, out of these 5 A's available, we have to choose 2 A's and then we have to arrange that. So how many ways of arranging these things is the question given to me. I said okay, in how many ways I can select, so since more number of things are given to me, so I'll first select things out of these 5, any 2. So in how many ways I can do that? Not 5C2, but the only way is 1, if you remember, right? So one way of selecting them, let's say I have got AA. Now 2 A's I am having and both of them are identical, so whichever A goes to first position and whichever goes to the second position, it does not matter. So in how many ways this can be arranged? This can be arranged in only one way. So if 5 A's are given to me and I have to take 2 A's from here and then I have to arrange it at two places, then that can be done in how many ways? One way only, right? This is an important thing. Alright, moving on to the next thing. Neither identical nor distinct objects arrangement. That means case number 3, that is the case when few objects are alike. Few are distinct. Let me tell you that over here 2 kind of cases will form again. One case will be in the thing when all objects are to be arranged. And another one is the way in which not all objects are to be arranged. I will talk about this. Don't worry. Okay, yeah. Over here, let me give an example so that you can understand better. Example. How many words can be formed by arranging the letters of the word let's say Naman. Now understand. How many words can be formed by arranging the letters of the word Naman? So over here 5 things are there and we need to form 5 letter words. All the letters of the word we need to arrange. So 5 factorial will not be the answer. Neither 5p5 will be the answer. Neither 5c5 into 5 factorial will be the answer. And neither you can apply multiplication rule. Yes or no? Can you understand this much? You understood this much? Yes. Okay, then what do we do? Okay, what we do is we first find out how many things are given to us. So sir, 5 things are given to us. Okay, if all of these are distinct, then the answer would have been 5 factorial. But over here, not all the objects are distinct. That's why we will see that how many n's are there, sir, 2. So that's why we will divide by 2 factorial. How many a's are there, sir, 2. So that's why we're gonna divide by 2 factorial. How many m's are there, sir, 1. So we're gonna divide by 1 factorial. That's it. So this many total 5 letter words can be formed by arranging the letters of the word Naman. So let me tell you this concept over here. I'm calling it as category 1. I'm calling it as category 1 problems in this particular subcategory. Okay. So in category 1, what we are saying that if we are having n objects in total, out of which A objects are of one kind, B objects are of another kind, C objects are of third kind, and rest are distinct. Let's say, then the number of ways of arranging those n objects is n factorial divided by A factorial divided by B factorial divided by C factorial. Here the thing is, all objects are needed to be arranged. All objects are needed to be arranged. Okay, if let's say I give you a problem like this, letters of the word, example, letters of the word arrange are to be arranged. How many words will be formed? How many words will be formed? So over here I am saying all the letters are to be arranged. Okay, can you tell me the answer? The answer is going to be 7 factorial divided by how many A's? 2 A's. How many R's? 2 R's. How many N? 1 N, 1 G and 1 E. So this many total words can be formed. These kind of problems are quite easy because they can be done with a simple formula itself, right? Okay. Talking about this category 2 problems. Not all objects are to be arranged. Not all objects are to be arranged. Then in this case, let's say problems like 4-letter word from the letters of the word, let's say assassination or examination. You might have seen these kind of problems, remember? Yes sir. Okay. So over here look, 4-letter word is only we need to form, and out of the letters given over here, not all are identical, neither all of them are distinct. Because if I say form 4-letter word by using the letters of the word Arvind, then that will not come in this category, because in Arvind, A-R-V-I-N-D, if this is the spelling, A-R-V-I-N-D, if this is the spelling, then you guys can feel that all the objects are distinct. So in the case of distinct objects, if you want to form 4-letter word, then you can apply the formula NPR. Yes or no? Over here NPR. So 6P4 is what you can apply, or 6C4 into 4 factorial, or 6 into 5 into 4 into 3 multiplication rule. Yes or no? Since all the objects are distinct or all the letters are distinct. But if I ask you form a 4-letter word by using the letters of the word assassination or examination, over here not all the objects are distinct. Not all the objects are identical, so that will fall in this category. And that too in the category when not all the objects are needed to be arranged. If all the objects are needed to be arranged, then the problem is going to be quite easy. In such kind of thing, what we do is we do case formation. In such kind of problems, we do what? We do case formation. Recall when we were understanding selection, okay, or combination, there also when not all the objects were identical, neither distinct, in that case also if we were selecting a few things, then we have done the case formation. So that particular case formation will be used over here as well in order to first select and then we're gonna arrange. So let's take this example up to understand this concept in detail. So talking about the category 2 problems over here. Okay, yes, 4-letter words from the word assassination. Okay, so over here not all the letters are to be used. So what we're going to do is we're going to use case formation over here. So first let me write down how many A's are there. So 3 A's are there. Okay, how many S are there? So 4 S are there. Okay, how many I's are there? I's are 2 in number. Okay, how many N's are there? N's are 2 in number. Okay, so this is 7 to 9 to 11, then 1 T, then 1 O, right? Okay, these are the things we are having. Okay, so here we are going to do the case formation. All 4 letters are distinct. Okay, case number 2, 2 letters same and 2 distinct, like AASI, 2 letters same, 2 distinct. Okay, third case, 2 letters of one kind and 2 of another kind, like AASS. Okay, then talking about the fourth one, 3 letters of one kind, 1 distinct, and the fourth one being all 4 are identical. I am giving you an example of all these 4 so that you guys can keep this thing in mind. Okay, over here the words like ASIN all are different. Okay, 2 letters are same means AA and SI. Okay, 2 letters of one kind and 2 letters of another kind means AASS. 3 letters of one kind means AAAI, and 4 letters are identical means SSSS. Yes, you understood the different cases. Okay, now the moment you have formed, these are the 5 cases which will be formed. So that will come through practice. You will have to figure out any other case is possible or not. So there you will have to practice a bit, and then you will master this art that whether the cases are going to form or not. Okay. So over here, since 1, 2, 3, 4, 5, 6 different letters are given to me and I want to select any 4, since the letters are all distinct, and if I see only distinct letters, then I have 6 in number. So out of 6 I can select any 4. This is selection I am doing. Arrangement I will do later. Okay. 2 letters same. Now if you see, I can take 2 A's, I can take 2 S, I can take 2 I, I can take 2 N, but I cannot take 2 T and 2 O. So if I am looking for these 2 letters same, then who can provide me? AA is there, SS I can do there, I can take, NN I can take. So out of these 4 bundles, if I take any one bundle, will I be having two identical things with me or not? The moment I have taken this AA bundle, I am having two identical things. The moment I have taken this SS things, I am having two identical things. Yes or no, everyone? Yep. Okay. Okay, and two distinct things I need to select. Let's say I have taken AA. Then if I have taken AA, then SINTO. These are the 5 things available for me to take two distinct things. SINTO. So 5C2 is the number of the ways of selecting two distinct things. Okay, I said we are done. Okay, moving ahead. Two identical of one kind and two identical of second kind. So over here, if you see the cases like AA, SS, II and NN. Out of these 4 bundles that I am having, I can take any 2 bundles. So 2 letters of one kind and 2 letters of another kind will be sorted out. Okay. 3 letters of one kind, if you look at this bundling, if you look at this particular bundling, then AAA can be there and NNN can be, sorry, SSS can be there. AAA and SSS. No other thing can be there because 3 I's are not there, 3 N's are not there, 3 T's are not there, 3 O's are not there. Okay. So out of these 2 bundles, I can take any one bundle. The moment I take any one bundle, then I am having 3 identical things with me or not? Yes. Okay. Let's say I have taken AAA bundle. The moment I have taken AAA bundle, then I will be left out with what? I will be left out with SINTO. And out of these 5 things, I can take any one thing. So 5C1. I said okay, moving ahead. If I am talking about all 4 being identical, then there is only one possibility, and what's that? SSSS, because not 4 A's are there, not 4 I's are there, not 4 this are there. So this is the one bundle I have selected, and that's it. Okay. Now the moment I have done the selection, I need to arrange these things. Okay. So these are 4 different things I have chosen. So in how many ways I can arrange 4 different things on 4 different places? 4 factorial ways. Okay, over here 2 things are same and 2 are distinct, and I need to arrange these 4 things on 4 places. So understand the problem this was involved. 4 things we have already chosen, that means now we have 4 things and we want to arrange them at 4 places, out of which 2 things are identical. So what we're gonna do is we're gonna do 4 factorial divided by, since 2 things are identical, so we're gonna divide by 2 factorial, yes or no? Since over here 2 things are identical. Okay, if we talk about this third one, then over here we are going to do 4 factorial divided by 2 factorial, 2 factorial. Why? Because 4 things are there with me, out of which 2 are of one kind, 2 are of another kind. That means 2 are identical, 2 are identical. So that's why 2 factorial, 2 factorial. I hope you understood this. Okay, talking about this, since I am having 4 things with me now, out of which 3 are identical. Look, AAA. So that's why I am going to divide by 3 factorial. And over here, if you see 4 factorial divided by 4 factorial, just add all these 4 cases. Add 1, 2, 3, 4 and 5. What you're gonna get is nothing but your answer. So what am I trying to tell you is, number 1 is the case formation. The case formation happens when neither all objects are identical nor all are distinct, and there also we need to take a few things only, not all the objects. So their case formation is required. So through case formation, first we do the selection, and after doing the selection we do the arrangement. I hope you guys are clear with this. I hope the concept is clear to all of you guys. Yes, everyone? Okay, moving on to the next thing. Now there are 2 specific P&C problems. Now there are 2 specific P&C problems are there. Specific P&C problems are there. One is gap method and another one is block method. Okay. Okay. Gap method is used whenever this statement is there. Hint. Whenever this statement is there, no 2 particular objects are together. Whenever this statement is there, then you can use gap method. And in order to apply block method, the hint is not all particular objects together. These are the hints. Whenever you see these kind of words, you can see that. Whenever you see these words, you can see that gap method can be applied. Whenever you see this kind of a thing, you can see that block method can be applied. Now let me tell you an example so that you can master the difference between these 2 things. Example. Let's say 5 boys and 4 girls are there. Okay, here also let's say 5 boys and 4 girls are there. Over here the problem given to me is no 2 girls are together. No 2 girls are sitting together. Number of the ways of arrangement will be what? Number of ways of arrangement will be what? And over here the problem will be like this. All girls are sitting together. Number of the ways of arrangement will be what? Can you understand the difference? Yes? Okay. If this is the case, then understand that over here the approach is, it is saying that no 2 girls are together. So first the people who can sit together focus on that particular thing. So over here guys can sit together. Now again I am telling you, look, no 2 girls are sitting together. So whenever it is given that no 2 particular objects are together, we will have to apply gap method. So here we need to apply gap method, and here not all particular objects are together, it is given to you. Then you apply block method. Over here it is given to me that all girls are sitting together. Okay. All particular objects, here all particular objects are given together. Okay. So all girls are sitting together, number of the ways of arranging will be what? Here it should be all particular objects together, not. Okay. This not is not there. Okay. Now understand this. While applying this method, over here it is given to me that no 2 girls are sitting together, that means boys can sit together. If the restriction is imposed only on girls, then that means no restriction on boys. So first I'll arrange these 5 boys. So 5 boys can be arranged in 5 factorial ways. So let's say these are the 5 places for the boys. Okay. Then around these 5 boys, if you see, how many places are there? Around these 5 boys, if you see, there are 6 places. Yes or no? Now, if in these 6 places, if girls are sitting, don't you think that no 2 girls are going to sit together, because in any 2 girl, if you see, there will be at least 1 boy. Yes sir. So in that case, no 2 girls are going to be together. Okay, but I have only 4 girls and I have 6 seats with me. So let me select 4 seats for the girls to sit. Let's say I have chosen this seat, this seat, this seat and this seat. Over here if you see, between these 2 girls, this boy is there. Between these 2 girls, this boy is there. Between these two boys, these two girls, this boy is there. So no 2 girls are sitting ultimately together, yes or no? But also observe that these girls can arrange among themselves, yes or no? So this is what going to be the answer. I hope you understood the approach. The approach is, first make the boys sit, because there is no condition imposed on the boys that how they needed to be sit. Okay, and then around those boys we are having 1 extra number of seats. So out of those total number of seats, select the required number of seats for the girls to sit. The moment you have chosen that, then arrange the girls onto that many places, right? Okay, talking about this particular thing, here what we're gonna do is, we're gonna bundle these 4 girls in a single group. So these are 5 boys and this is 1 bundle of the girls, because we want them to stay together. So ultimately this is we will be considering it as 1 block. So 5 boys and 1 block. No condition imposed on boys. So 5 boys will be considered as 5 different blocks. Whereas all the girls are together means the girls will be considered as a single block. So in total we are having 6 blocks. So 6 blocks can be arranged in how many ways? 6 factorial ways. Now let's say these are the 6 places at which we have arranged these 5 boys and 6 girls. Let's say this is the place where the girls bundle has been put on. Now if you zoom in, over here these are 4 different places in which 4 girls are sitting. Yes or no? So these 4 girls can interchange among themselves. So that's why this 4 factorial will come. So that is what I am saying. 2 specific P&C problems are there. One is gap method, one is block method. Apply gap method whenever the problem says no 2 particular objects are together, and apply block method whenever the question says all particular objects are together. These are the problems I have taken. Keep these problems in your mind so that you can efficiently solve whatever problems are being asked from you in the given questions. Okay, yes. Now moving on to the next thing, and that is derangement. Moving on to the next thing, and that is derangement, kids. Derangement. Derangement. Okay. Derangement is nothing but the opposite. Derangement is nothing but the opposite of arrangement. Okay. Derangement is nothing but the opposite of arrangement. Opposite of arrangement. Understand it with an example. Let's say I have given you 4 different letters. This is letter 1. This is letter 2. This is letter 3. And this is letter 4. Obviously, the correct addresses of this letter 1, if you see, it has to go to address 1, it has to go to address 2, it has to go to address 3, but it has to go to address 4. These are the correct addresses. Okay, and these are the letters. If you send, if the postman is such that he's high on something and he delivers the letters all at wrong places. That means letter 1 can go anywhere else, but it is not going to A1, A2, A3, A4. No, it is not going to A1, but it can go to A2, A3, A4. That means it is going to its wrong place. Letter 2 is not going to A2, but it can go to A1, A3, A4. Letter 3 is going to A1, A2, A4, but not A3. Letter 4 is going at wrong place, that is A1, A2, A3, but not at A4, that is at the correct place. So if I want to send all letters at wrong places, means I am deranging these things. I am deranging these things. You understood the concept of derangement, everyone? Anyone is having any confusion in this? Do let me know. Okay. So the formula for that is n factorial times 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on. Till where? Till 1 by n. Okay. Till 1 by n factorial we have to go. So over here, if 4 letters are given to me and all of them are going at wrong places, then the number of the ways that can be done will be like this. These are alternate plus minus signs that do come. Okay, so these are the total number of ways. 4 factorial times of 1 minus 1 plus 1 by 2 minus 1 by 6 plus 1 by 24. Okay, 1 goes away. Over here 12 minus 4, that is 8 plus 1, 9 by 24 into 24, so that is equal to 9. So there are 9 ways in which all the letters can go to wrong place. Okay, a lot of people think it like this. Letter 1 can go to 3 places, sir, because it can go to A2, A3, A4. Letter 2 can go to 3 places, sir, A1, A3, A4, 3 places. This can go to 3 places, sir, A1, A2, A4. This can go to 3 places. That will be wrong. Why? Because and each and every letter has to be delivered, so they will say that, sir, 3 to the power 4 will be the answer, but no. Why? Because if letter 1 is going to, let's say, address 2, then letter 2 can go to letter 1, address 1, address 3, address 4, no issues. But when you considering this possibility, then letter 3 is having 3 choices. So again, if you are taking 3 choices, then letter 3 can go to address 2 as well, no? So at one address there will be multiple letters going on in this particular case. So that cannot happen. At one place only one letter has to go, and that too wrong one, right? At every place only one letter has to go, and that too wrong one. So that is what? Nothing but derangement. So the derangement's formula is like this. Now the formula is, people are not able to analyze this formula pretty well. So it's like that meme which you might have seen, that Akshay Kumar's meme is there. I would have shown to you, but since this is a one-shot session, so I will not be using those memes, because otherwise it will take me so much time. So, but remember this formula, derangement means at every place one thing has to go, and that too wrong one. Okay. Yeah. Okay, the problems can be like this as well. The problem can be like this as well. 4 letters are there. 4 letters are there. 4 letters are there. One has to go to correct address. Rest at wrong addresses. So in this variety of questions, what you do is you first find out the letter which you send to the correct, which you want to send to the correct address. So there are 4 possibilities for that, either letter 1, either letter 2, either letter 2, either letter 3 or either letter 4. So first you will select that letter which you want to send at the correct place. So that can be done in 4C1. Now ways. Now the remaining 3 letters you want to send at wrong places. So for that you will do derangement. So 1 minus 1 by 1 factorial plus 1 by 2 factorial plus 1 minus 1 by 3 factorial. Since 3 things are there, that's why we will stop at 3 factorial only, because we want to ultimately send 3 things at wrong places. Okay, we will multiply these 2 things. Why we are going to multiply? Because we have to do both the tasks. We have to send 1 letter to the correct address as well as we have to send the 3 letters at the wrong places. That's why we will multiply the 2 cases, and that is going to be our answer. I hope the problem is clear to all of you guys. Anyone is having any difficulty in this, do let me know. Now talking about distribution. Now talking about distribution of objects. Distribution of objects. Now again, there are 2 varieties of distribution of objects. One is distinct objects and another one is identical objects. I hope that you people have eaten golgappas, or we say pani puris. Yes, you love pani puris? Okay, all the pani puris are identical, yes or no? That's why I am taking the example of that. And distinct though you can definitely remember, not an issue. Okay, let me tell you this example. In front of golgappa wala or pani puri wala, what happens? We guys act as beggars, right? We take our like this, and he gives pani puri to us, yes or no? So here we use beggar method, because we are begging him to give us pani puri is beggar's method. The beggar's formula is there, n plus r minus 1 c r minus 1. N total things, r number of people in which these things are to be distributed, number of people. So this formula n plus r minus 1 cr minus 1 is used whenever you are given n identical things and you have to distribute it among r number of people such that any guy can get any number of objects. That means let's say a pani puri wala is having 10 pani puris, and let's say 3 people are standing in front of him. It's his choice that if he want to give all the 10 pani puris to a single guy, he can, because it's his pani puri. I hope you understood this. Such that any guy can get any number of objects. It can be the possibility that one guy is getting 10 pani puris, another one is getting 0 pani puri, another one is getting 0 pani puri. But I'm saying all the objects are needed to be distributed. He cannot take the pani puris with himself, right? He has to sell those pani puris. That's why he has come to the place, right? Okay, but he can also do the distribution like this. To the one guy he is giving 9 pani puris, to the another one he is giving 1, and to the another one he is giving 0 pani puris. This can also happen that he is giving 8 pani puris to the first one, or 1 to the another one, and 1 to the another one. He can also do the distribution like this. He is giving 8 pani puris to this, 2 to this, and 0 to this. He can also do the distribution like this, 5 to this, 5 to this, and 0 to this, like this. Okay, yes, but he cannot take pani puris from the people who are coming, and he cannot give -1 pani puri to this, -2 pani puris to this, and 13 pani puris to this. Minus means he is taking something. So pani puris wala cannot take pani puri from the people. He will give pani puri to the people, right? I hope you understood this. So what am I trying to tell you over here is, if identical objects ka distribution is there, you will keep that golgappa or pani puri wala's example in your mind. Here we use beggar's method because we beg him, we take our bowl and ask him to put pani puris in it. So that's why we use beggar's method in the case of identical objects distribution. And also the number of the ways of distributing is n plus r minus 1 cr minus 1, where n are the total number of the things and r is the number of the people standing in the queue to have those identical objects with them. Okay, here any guy can get any number of objects. If we are talking about distinct objects distribution, then let me tell you one thing over here. Identify the things, the thing which we want to distribute, and see for every such thing, how many choices are there. Okay, yep. Here also any guy can get any number of objects. Here also any guy can get any number of objects. Let me tell you examples of both the cases. Okay, yes. So let's say that you have 10 1 rupee coins. There are 4 beggars standing in front of you. Distribute them. In how many ways the distribution can be done? Okay. Now all the 1 rupees are going to be identical. So all the 1 rupee coins are identical. So this problem is going to be identical. Okay. Yep. Okay. Let's say you are having 1 dairy milk, 1 samosa, 1 apple, and you are like, okay, I'll go home and I'll eat all of these 3 things. And what happens when you go to your home? You find 3 friends in the middle, and they are like waiting for you. Okay, today we're gonna eat those things. Okay, so you cannot say no to friends, right? Okay, so what will happen? These are different things. So ultimately you have to distribute these 3 things to these 3 friends such that any friend can get any number of things. That means there can be one possibility that a friend is taking all the 3 things and other 2 friends are like, hum to piche reh gaye, we are not getting anything. There can be one possibility also that all the friends are getting 1 things. There can also be another possibility when one of the friend is getting 2 things and one of the friend is getting only 1 thing. So that thing is there. Any guy can get any number of objects. And over here the identical objects are there. That means beggars method. Okay. So over here I told you a formula. This is quite easy to understand. N plus R minus 1. N is 10. Okay, R is the number of the beggars, so this 4, C 4 minus 1. So this is nothing but how much? 13C3. I hope you can evaluate the value of 13C3. So 13C3 number of ways of distribution are there in that particular scenario. Over here, since the objects are all distinct, so what you're gonna do is, you gonna first find out the object which is to be distributed. Let's say 1 dairy milk which you want to distribute. So this is having how many choices? Let me take one more thing over here. What should we take? 1 paratha. Okay. Okay. So that the clear understanding will come. So whenever you are distributing distinct objects, you will first see the object which is to be distributed. Let's say this dairy milk. How many choices are there for this dairy milk to go? This can go to 3 friends. So 3 choices for this. Similarly, the samosa can go to 3 choices because any guy can get any number of objects, means a guy who has already got dairy milk can also get samosa. Okay, yes, 3 choices. The apple can also have 3 choices, and the paratha is also be given to 3 people. So 3 choices for that as well. And as I told you, you cannot take these things to your home. You have to distribute it anyhow. So that's why this thing also needs to be distributed, this thing also needs to be distributed, this thing also needs to be distributed, this also. So we're gonna multiply. So over here the answer is going to be 3 to the power 4. Right? I hope you understood this. Now a lot of times what happens that people write down the answer as 4 to the power 3 and not 3 to the power 4. So that's why I told you always pick the thing that is needed to be distributed. So over here these are the things which are needed to be distributed. So pick this thing up, and this can go to how many people? 3 people. This can go to how many people? 3 people. This can go to how many people? 3 people. This can go to how many people? 3 people. And that's why I have written it like this. So it is a very important thing. If you are following what I am saying in the questions, definitely there will be no confusion at all in order to solve the questions. Alright, moving ahead. Let me give you cases, problems where beggars method is used. Beggars method is used. Okay, yep, okay. Let's see this. X plus y plus z is equal to 13, and x is greater than equal to 0, y is greater than or equal to 0, and z is greater than equal to 0. This is given to you, and the question is asking you find number of non-negative integral solutions, non-negative integral solutions, negative integral solutions, integral solutions, okay, non-negative integral solutions. That means what? It is asking that 13, 0, 0 will solve the problem, also 0, 13, 0 will solve the problem, also 0, 0, 13 will solve the problem, also 12, 1, 0 will solve the problem, also 12, 0, 1 will solve the problem. These are basically x, y and z. These are values of x, y and z, and so on and so on, like this. So how many solutions like this will be formed is what the question asking from us. So understand this problem like this, that there are 13 things in total which you have got from your home, and there are 3 people who are standing in front of you, and to the first person you have distributed x number of things, to the second person you have distributed y number of things, and to the third person you have distributed z number of things, okay. Yes. So in that case you have to find out the non-negative integral solution, means these values can never be negative. You cannot take anything from beggars, right? You have come there to distribute, not to take anything from them, right? Yes. So non-negative integral solutions means you cannot, x cannot be minus 1, y cannot be minus 1, minus 2, like that, right? Because minus means you are taking anything from that. You guys can feel it like this, okay. So what we are having with us is, I hope the problem is clear to all of you guys, right? Okay. So there are 3 people standing, and 13 things are needed to be distributed, and these are identical in nature, okay. So if you apply the formula 13 plus 3 minus 1, see 3 minus 1, because 3 people are standing. To the one person you have given x number of things, to the second person you have given y number of things, to the third person you have given z number of things. So this formula you can apply, and these are the total number of ways, means this is nothing but how much? 15C2. These are the total number of solutions like this, 15C2. Can you imagine this number? That is going to be 15 times of 7. 15 times of 7 is going to be how much? 105. So 105 solutions like this can be written. I hope the problem is clear to all of you guys. Now sometimes what happens, that it is given to me that x is, okay, you cannot distribute half of things, okay. Distribution is to be done, distribution of objects will be done in complete form. In complete form means what? Let's say the Pani Puri wala is distributing Pani Puris. He cannot give half of the Pani Puri to one guy and half of the Pani Puri to another guy. He has to distribute either it completely, right? Completely he will give one single Pani Puri only. He will not give dhai Pani Puri to this and half Pani Puri to this. This can never be the possibility, right? And also talking about this distinct things objects, we have seen dairy milk, either he will give the complete dairy milk to the persons. He cannot distribute it, cut it, and can divide and distribute. He cannot do that, okay. Yep. Otherwise the people will not eat it. You can feel it like this, okay. So in complete form distribution will be done. That means one dairy milk will go to a single person, one samosa will go to a single person, one apple will go to a single person, one paratha will go to a single person. It cannot be like that ki one paratha is distributed among 2 people, okay. This will not be that. Okay, so I hope you understood this one. Okay, so let's say if it is given to me that x is greater than 0 and not x greater than or equal to 0. So in that case, x greater than 0 means x has to be either 1, 2, 3, x cannot be 1.5, 1.7 and so on. I hope you understood this much, right? Okay, so can I write down x greater than 0 as x greater than or equal to 1 in these particular problems? Yes, and then you will solve. Okay, this can also be one problem, that x plus y plus z is equals to 13 is given to you, and it is given to that one of the people standing is your favorite one, and you have to give 3 things to him. This can also be one such question, that x plus y plus z is equals to 13 given to you, and one of the person is receiving 3 things. This has to be there. Let's say x is always greater than or equal to 3, it is given to you, and y and z are same conditions given to you. So in that case you will first give 3 things to that guy. So you will be left out with 10 things only, and then you will distribute those 10 things among 10 people such that any guy can get any number of objects, right? So in that case 10 plus 3 minus 1 C3 minus 1 will come out to be the answer, that is 12 C2. So if let's say it is given to me that a particular person will be getting 4 objects has to have 4 objects. So first we will give those 4 objects to that guy so that we can come on to remaining things, and now we will distribute it as if any guy can get any number of objects. Okay, I hope you understood what am I trying to convey over here. Yes, so this will solve a lot of your problems. Okay, division of distinct objects into groups. Division of distinct objects into groups. Okay. Okay, so that thing is there. All right, now I'll move towards a few other things. Circular arrangements we're gonna take. Okay, now we're gonna take circular arrangements. Circular arrangements. We have seen that in a row, if n people are to be arranged, then that can be done in n factorial ways. But in circular arrangements, n distinct things can be arranged in n distinct things can be arranged in n minus 1 factorial. Why? Because a circle does not start from anywhere, that's why. Okay, let's say I have given you five people and I have told you to arrange them on a round table. Okay, so that can be done in 5 minus 1 factorial. But if I say arrange these 5 people in a row, so that can be done in 5 factorial. Okay, I hope this is clear to all of you guys. Okay, now there are some cases in which anti-clockwise and clockwise sense is same. Anti-clockwise and clockwise sense is same. Let me tell you, clockwise sense is same. Like in the case of necklace, like in necklace and garland. Let me give you an example. Let's say this is one of the necklace. Over here diamond is there. Over here platinum is there. Over here let's say silver is there. And over here let's say aluminum is there. Different kind of a necklace I am forming. Okay. If I give you one necklace like this, over here diamond is there. Over here platinum is there. Over here silver is there, and over here aluminum is there. Let me write down these things neatly so that you can understand better. This is diamond, this is platinum, this is silver, and this is aluminum. Okay. Over here is diamond, over here is Ag, aluminum, over here is platinum, and over here is aluminum. Are these two necklaces same or distinct? They are same necklaces, because it does not matter. Look, if you are wearing this necklace and if you just rotate it like this will become this very same necklace or not? So necklace can be worn like this as well as in the opposite way. Like this chain can be worn like this, and by rotating it as well the chain will remain same. Yes or no? So here these two cases are identical. That means clockwise sense and anti-clockwise sense are same. So in that case, number of the ways of arrangement is going to be divided by 2. These many arrangements divided by 2 is going to happen. I hope you guys are clear with this. Yep. Okay. Alright, moving on to the next thing. Now, I hope you know what is the meaning of collinearity. On a circle, let's say this is one of your circle. If you take any 3 points on this circle, any 3 points on the circle, any 3 points on a circle are always non-collinear. Matlab they will never be lying on the same line. Yes or no? So this is the speciality of a circle, that any 3 points on a circle are always non-collinear. Matlab they will never lie on a same line. Okay. If I ask you in this, let's say n points are given to me on a circle. How many straight lines will be formed? So you'll have to understand that in order to form a straight line, what you need? In order to form a straight line, you will need nothing but 2 points. So out of n distinct points, the moment you take any of the 2 points, you're going to have a straight line, yes or no? So the NC2 number of lines will be formed. Now there are cases in which it is asked that how many triangles will be formed. So understand that in order to form a triangle, what you need is any 3 points. So NC3, number of the ways of selecting 3 points out of the n distinct points available on a circle. So NC3, number of triangles you guys can form. Moving on to the next thing, what happens that let's say this is one circle given to you and over here n points are given to you. And if n points are given to you, then this can form an n-sided polygon as well. Yes or no? Okay, now the problems can be asked that n points on a circle are given to you, n points on a circle are given to you. How many sided polygon will be formed? If n points are given to you on a circle, then n sided polygon will be formed, yes or no? N sided polygon will be formed, obviously. Okay. Now side is also a line, yes or no? A side is also a line. Line can be of two categories over here. Line, either the line will be a side of the polygon or it will be a diagonal of the polygon, yes or no? So in this variety of problems, it can also be asked to you that what are the number of the diagonals can be formed of an n-sided polygon. So you can see that total number of lines were what? NC2. The sides were n in number, so number of diagonals will be what? Number of diagonals will be what? They will be equal to NC2 minus n, that's it. So this many total number of diagonals will be formed. A diagonal is what? A diagonal is formed by joining any two non-adjacent points, because if you join adjacent points you will get a side, yes or no? Yes. So number of diagonals in that case will be nothing but NC2 minus n. Yes, I hope you understood this, everyone. Yep, okay. Now there can be multiple problems like this. Okay, let me give you an example. Let's say I have been given these are the 3 points and 1 point is over here, 1 point is over here. These are the only 3 collinear points given to you. How many total lines will be formed? Okay, these are the 1, 2, 3, 4, 5. These are the 5 points given to you. 5 points are given to you, out of which 3 are collinear. Then how many total lines will be formed? These kind of problems also do come. How many total lines will be formed? In the case of points on the circle, there were no 3 points collinear, but there in real life there can be collinear points as well. So these kind of problems also do come. How many total straight lines will be formed? So what you will do is you will first assume that all the lines are, assume that no 2 points are collinear. So in that case the total lines will be like this. But if out of these 3 points, if you pick any of the 2 points, you will get those 3C2 number of lines which are same, yes or no? But you will, so that you will remove it from there. Understand? If out of these 5 points, if you take any 2 points, you will get a line, but out of those lines, this many number of lines will be counted twice. Why? Because this line, they are all same, isn't it? So these 3C2, that is 3 number of lines have been, these are all, because line is never ending, yes or no? So and 1 we need to add, because at least these lines will be counted at least once, no? So these are the total number of lines. This plus 1 is very important, because these are same lines, but they are needed to be counted for once at least, right? Because one line will be counted, na? Yes, that's why this plus 1 is there. Okay, so this one thing is there. Also there can be problems like this, ki how many triangles will be formed. Now if you take all the 3 points from here, the triangle will not be formed, yes or no? If you take 1 point from here, one this and one this, the triangle will be formed. If you take 2 points from here and 1 point, either this or this, the triangle will be formed. The only case in which triangle will not be formed is if all the 3 points are taken from this particular case. So if I ask you like this, how many triangles are formed? How many triangles are formed? So here you need to put into cases that if I am taking 2 points from here, so 3C2, then 1 point from here, that is 2C1. Either this will be the case, or means I will do the addition. If I am taking 1 point from here, 3C1, and 2 points from these two, 2C2, the triangle will be formed. But it cannot be the case that you take none of the point from here, because there are only rest two of the points only. So this many total number of triangles will be formed. So that case formation is what you will have to do. I hope the problem is clear to all of you guys. Also there is one more category of the problem, that let's say these are a few parallel lines given to you. Okay, like the problems of chessboard. Okay, these are all identical shapes. This shape, 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 this. They are all same. Like in the chessboard it happens. So look, how many are, let me tell you one thing, a square is also a rectangle. A square is also a rectangle. But a rectangle is not a square. Okay, yep, but not vice versa. So if I ask you how many rectangles are formed over here? How many rectangles are formed over here? So you will see over here that if I take any two vertical lines and any two horizontal lines, the rectangle is going to form. Yes or no? In order to form a rectangle, what you need is two horizontal lines and two vertical lines. So over here, how many vertical lines are there? 1, 2, 3, 4. So out of these 4 vertical lines, take any one, take any two. And out of these 1, 2, 3, 4, 5, 6, 7, take any two horizontal lines out of these 7. Yes or no? A rectangle will be formed. Yes or no? So this many total number of rectangles will be formed. We will multiply these two cases because in order to form a rectangle, we need two vertical lines and two horizontal lines. I hope you understood this. Okay. How many squares will be formed? How many squares will be formed? Okay, now how many squares will be formed if you want to master that? Okay, so you can see 1, 2, 3. Okay, then 3 into 1, 2, 3, 4, 5, 6. Okay, so this is how much? 3 times of 6. Okay, now if you are picking the squares of 2, that is of these shapes. Okay, so 1, then you will move from here. No, this is not a square. Let me tell you this thing again. So if you are forming a square, then 1 will be this. This we have already counted, okay? Okay, then this. Then 2 times of how many such thing will be there? 2 times of 1, 2, 3, 4, 5. 2 times of 5. Then 1 times of 4. So this many total number of squares will be formed. Just add down these things and the question is done. Okay, 3 times 6. Why this 3 times 6? 1, 2, 3 and 1, 2, 3, 4, 5, 6. That's why 3 times 6. Then if you are taking the squares like this, these squares, then it will be 1 and another one will be 2. Then this will be 3. This will be 4. Then this will be 5. Then this will be 6, then this will be 7, this will be 8, this will be 9 and this will be 10. Yes or no? So that's why 2 into 5, 10. I hope you understood this and this is going to give you the answer. Okay. Alright, moving ahead and talking about few other things, let me tell you the problems involving inclusion and exclusion principle. Inclusion and exclusion principle. Inclusion and exclusion principle and exclusion principle. Inclusion and exclusion principle. I hope that you people have gone through this formula in sets. NA union B is equals to NA plus NB minus NA intersection B. And also this formula that NA complement B complement, okay, intersection is equals to total minus NA union B. These are the two formulas. I hope you remember. Let me give you an example where whenever in the problem either or comes, find out this. Either or. Whenever in the problem either or comes, use this form, find out this particular thing, and whenever in the problem neither nor comes, use this particular thing. I'll tell you an example. Example. Okay, find total number of things, total number of total number of two-digit numbers, either divisible by 2 or 5. Find total number of two-digit numbers either divisible by 2 or divisible by 5. So first you will take NA, that is the number of the things which are divisible by 2. So these numbers are what? These numbers are 10, 12, 14, 16, 18 and so on till 98. So can you first find out how many numbers are these? Okay. And then the numbers which are divisible by 5, can you find it out? Okay, they are 10, 15, 20, 25 and so on till 95. Okay, can you find out how many numbers are these? 90. Okay, this is an AP. So 98 is equals to A plus N minus 1 into D. So 88, 44, 45. So these are total 45 numbers. Okay, these are how many? These are 95 is equals to A plus N minus 1 into D. So this is 85, 85 divided by 17, 17 and 18. So these are 18 in number. Okay, if I am asking you numbers either divisible by 2 or 5, that means I need to find out this. So can I first also find out the numbers which are divisible by 2 as well as divisible by 5? So those numbers are what? Those numbers are 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 90. So these are total how many numbers? 10 numbers, I guess. No, 9 numbers. So these are the 9 numbers which are, this is NA intersection B. Okay, this is NA, this is NB, and what we need to find out in the problem is nothing but NA union B. I hope you understood this particular thing, everyone. There has to be no confusion at all. If I ask you, find the total number of 2-digit numbers which are neither divisible by 2 nor divisible by 5, so you will use this formula. I hope the inclusion exclusion principle is clear to all of you guys. Just keep this problem in your mind and everything will be clear to all of you guys. Now, okay, one such problem is of rank. Let me tell you rank. There can be 2 such problems. One in which all the letters are distinct. Let me give you an example. Okay, physics. Yes, okay, and another one will be of Wallah. So this is category 1 problem. This is category 1 problem. And this is category 2 problem. Okay, yes, the category 1 problem is the one in which all letters are distinct. Okay, physics, let me put it as physics only. All letters are distinct, and this is another category in which few letters are identical. Few letters are identical. Whenever, look, if I ask you how many total words can be formed over here, you will say, sir, 6 distinct letters are there, so 6 factorial number of words can be formed. Over here, if I ask you, oh, how many letters of the word, how many 6-letter word can be formed, you will say, sir, 6 factorial by 2 factorial, 2 factorial, right? Total number of words. Let's say I am arranging these words in a dictionary, so 6 factorial, that is 720 words will come, and over here 720 divided by 4, right? So that will be how much? That will be 90. Right? 90, no, not 90, 720 divided by 4, if you do, so that will be 180, right? Over here 180 numbers will be written in dictionary, and over here 720 numbers will be written in a dictionary. So physics will come at what place and Wallah will come at what place in these two separate dictionaries is what the question given to us. Okay. Now in these variety of questions, first we write down in the ascending order. Ascending order or in alphabetical order, the things do come out how? Alphabetical order. Alphabetical order. So over here, the alphabetical order says that E, F, G, H, I. Okay, C, H, I, O, P, Q, R, S, Y. This will be the alphabetical order, yes or no? And over here, if you see A, L, E, F, G, H, I, J, K, L, okay, H, L, L, W. This will be the alphabetical order. Okay. Now, over here, first the numbers which will be starting with C will be formed. Okay. Yes. So over here 5 factorial will be words which will be forming with C. Then the words with H will be formed. Over here 5 more factorial, then the words with I will come, 5 factorial because C, H, then I, then P will come, and over here is what physics will come. Yes, okay. In these numbers also if you see, first P, C numbers will come, so these will be 4 factorial. Okay, then P, H will come, and this only, in this only physics will come. So I am going to zoom it further. In these numbers only, first P, H, C, and then 3 factorial numbers will come, then phi will come, right? So these will be 3 factorial, then phs will come. So 3 factorial numbers from here, and then phy will come, and over here only physics will come. So I am zooming it again. Then after phi c will come. So over here 2 factorial words, then phy will come. So 2 factorial words, then phy s will come. So here physics will come. So then physci will come, that is 1, and then physics will come. Yes or no? So this is how the dictionary will be looking like. So 5 factorial is how much? 5 factorial is 120. So this is 120, 120, 120, then 24, then 3, 6, then 6, 6, and then 2, 2, 1, and then the word physics will come. So that is how, look, the moment the word physics is getting formed, we have zoomed in, right? I hope the approach is clear to all of you guys. Then moving about Wallah. So over here A, L, H, L, L, W. This is the alphabetical order. Okay, first the word starting with A will come. Okay, over here if you do the arrangement, these are the 5 things out of which 2 are identical. So 5 factorial divided by 2 factorial. Then moving ahead, the word starting with H will come. If you are writing down the words with starting with H, then 5 factorial by 2 factorial, 2 factorial will come. Then the words starting with L will be written. If you are writing down the words starting with L, then these are the 5 letters out of which 2 are identical. So 5 factorial by 2 factorial. Okay, then the words starting with Wallah will come. Okay, yes, in this category only Wallah will come. So over here the next category will be WA, and inside this only Wallah will come. So let me zoom in this further. So then this. So inside this Wallah will not come. So we can say that these are 3 factorial divided by 2 factorial. L, L and H is remaining. Okay, then WAH will come. So inside this also Wallah will not come. Okay, then WAL will come. So inside this Wallah will come. So I am zooming it further. So WAL, inside this Wallah will not come. So L and A are the two, L and H are the 2 things there. So 2 factorial. Then WALH, this will come. So over here if you do, so 1 L and 1 H is there. So 2 factorial. And then if you see WALL, AH has to come. So this is also you need to count. So look, this plus this plus this plus this plus this plus this plus this and then plus 1 is going to be your rank bacha party, right? That's it. So this is another kind of problem which you must keep in your mind. Okay, yes, there is 2 more category of problems. One is number of divisors. Let me talk about that. Let's say I have given you a number. I will give you an example as well over here. Let's say I have given you a natural number n, and it can be written like this: p to the power a into q to the power b into r to the power c, where p, q and r are prime numbers. Where p, q and r are prime numbers. Prime numbers means the numbers which are divisible by 1 and itself. Okay, yes. Then total number of divisors of n. Total number of divisors of n, if I am asking you, then that will be equal to a plus 1, that is b into b plus 1 into c plus 1. Let me give you an example. Number of divisors of 72. If this is the problem asked to you, divisors of 72, then what you are going to do is 72 can be written as 2 into 36, 18, 9. 2 to the power 3, that is 6 into 6, say if you divide 12. Okay, so that should be 4, right? Wait, 72 ko if you factorize, 2, 36, 2, 18, then 2, 9, 3, 3, 1. Yes, this is going to This is what you're going to write down. Yep. Okay. So as per the formula, the thing is what? The number of the divisors will be what? You take the power and add plus 1. Take this power, add 1 to this. Take this power and add 1 to this. Multiply all of these things. So 4 times 3 is 12. So 12 number of divisors the 72 will be having. 1, 2, 4, 8, 9, 6. Right, like this 12 number of divisors will be there. 72 itself, 36, 18, like this. Okay, yep. So this is the formula. Now why this comes? Because look, 2 to the power 3 is there. So I can take at least, I can take 2 to the power 0. I can take 2 to the power 1, I can take 2 to the power 2, I can take 2 to the power 3. So there are 4 choices for me to have the power of 2's. Similarly, I have 3 choices from here. 3 to the power 0, 3 to the power 2, 3 to the power of 0, 3 to the power 1, 3 to the power 2. And that's why this 3 is written. Right. So if you understood this, understood this thing, then that is great. If you haven't, then that is also fine. Then another thing is sum of divisors, sum of these divisors. So that can be found out like this: p to the power 0 plus p to the power 1 plus p to the power 2 and so on till p to the power a times q to the power 0 plus q to the power 1 plus q to the power 2 and so on till q to the power b, and then c to the power 0 plus r to the power 0 plus r to the power 1, r to the power 0 plus r to the power 1 plus r to the power 2 and so on till r to the power c. That's it. This is sum of the divisors. Over here, let's say I am asking you sum of the divisors, then you're going to do what? 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 times 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2. Okay. If you multiply this and this, look, one of the factor it is there, 2 to the power 0 with 3 to the power 1, another factor 2 to the power 0 with 3 to the power 2, another factor 2 to the power 1 with this, another factor 2 to the power 1 with 3 to the power 1, another factor 2 to the power 1 with 3 to the power 2, another factor 2 to the power 2 with 3 to the power 0, another factor 2 to the power 2 with 3 to the power 1, another factor 2 to the power 2 with 3 to the power 2, another factor 2 to the power 3 with 3 to the power 0, another factor 2 to the power 3 with 3 to the power 1, another factor 2 to the power 3 with 3 to the power 2, another factor. So these are total 12 factors, and this can be written 1 plus 2 plus 4 plus 8 times 1 plus 3 plus 9. So you know how to multiply it now. Then the sum of the divisors is clear to all of you guys. So this is number of the divisors thing. You must be clear with this. Okay. Sometimes it is also asked to you in the problem that how many even number of divisors are there. So if I am asking you even number of divisors, then you cannot take 2 to the power 0 from here, because you have to take at least 1, 2. Then only the number will be divisible by 2, or it will be an even number. So there, if you talk about the possibilities of having 2 to the power in it, then it will be 3 only: 2 to the power 1, 2 to the power 2, or 2 to the power 3. Here you cannot take 2 to the power 0. So that's why 3 possibilities from here, and if I want to form an even divisor, then there is no role of 3 in it. So from here I can take 3 choices. Okay, so 3 into 3, 9 choices will be there. So there will be 9 number of divisors which will be even in number. Okay, now exponent of prime number p in n factorial. Let's say an example, the formula over here is like this. The formula is this: greatest integer of n by p plus greatest integer of n by p square plus greatest integer of n by p cube plus greatest integer of n by and so on. Okay, never ending. Okay, let me tell you the thing. 10 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 6 into 7 into 8 into 9 into 10, everyone. Okay, if you collect the power of 2's from here, then you can see that 1 is coming from here. Okay, 2 will be coming from here. Okay, 1 will be coming from here. Okay, 3 will be coming from here. Okay, then 1 will be coming from here. So this is 2 to the power 3, 2 to the power something. Okay, if we talk about the power of 3, then power of 3 will be coming 1 from here. Okay, 1 from here. Okay, then 2 from here. Okay, then 4 is not a prime number. Okay, talking about 5, so 1 will come from here, and then like this numbers will be forming. So what is the power of 2 in it? This is the power of 2 in it. 3 plus 4, 7, 8. 2 to the power 8 is there in 10 factorial, right? So one way is doing this. But let me tell you, this can be a bit complicated. That's why I am asking you, whenever a prime number p's power in n factorial is asked, like over here, if I asked you what is the power of 2 in 10 factorial, so this formula can be used. So the formula, let's first apply the formula. 10 divided by 2 greatest integer function plus 10 divided by 2 to the power 2 greatest integer function plus 10 divided by 2 to the power 3 greatest integer function, 10 divided by 2 to the power 4 and so on. Okay, let me talk about this thing. 10 divided by 2 is 5, the greatest integer of 5 will be 5 only. Okay, 10 divided by 4 is 2 point something, the greatest integer will be 2. Okay, over here 10 divided by 8, the greatest integer will be 1 because it will be 1 point something something. This is 10 divided by 16, so it will be 0 point something, the greatest integer will be 0. Okay, 10 divided by 32 will come in the next. Okay, that will also be give 0. Now all the terms will be giving 0, 0, 0 only. So the answer is coming out to be 8. Look, from here also 8 is coming and from here also 8 is coming. Again, I am telling you this formula will be used only when P is a prime number. Let's say if I am asking you what will be the power of 6, you cannot use this formula. In order to form 6, you will have the power of 2 first, then the power of 3 individually. Then from there you will see either the power of 2 is minimum or power of 3 is minimum. Because in order to form a 6, you need 1, 2 and 1, 3. So whichever power of out of 2 and 3 is lesser, that many 6s can be formed. Okay. I hope you understood this concept. So one way is this. Okay, how this formula comes into the picture? Look, these are the number of the numbers in which 2 is coming once. 5 are such numbers. Okay, these are the numbers of numbers in which 2 is coming twice. So 2 is coming twice here and here. That's why this 2 is coming. Okay, these are the number of numbers in which 2 is coming thrice. There is only one such number. These are the number of numbers in which 2 is coming 4 times. There is no such number in which 2 is coming 4 times. I hope you people understood this concept. Right, so whatever we have learnt in this chapter, I think is clear to all of you guys. So I'll say that now if you apply the things in the manner I have taught you, it will be very easy for you to master this particular topic, because over the years I have seen that the kid is not able to find out where to apply a particular concept. Where to apply NCR, where to apply NPR. In every time whenever the problem is of combination, the kids apply NCR, but that is not the case. I have tried my level best to give you the explanation for each and every concept which is there in the particular chapter within the very short span of time. So I'll now recommend you to solve JEE mains previous year questions and then slowly, gradually move towards JEE advanced questions as well. In JEE mains, it has been observed that committees, the questions of forming committees has been asked very regularly. So that is another an easy category only. But I think if you have gone through this lecture entirely, then you would have understood each and everything. So the next lecture is going to be on sequence and series. So watch that lecture as well, because these are some easy kill topics which are there in the JEE syllabus, and definitely you can master these topics to do good in your JEE examination, and also revise these topics at this moment itself, because the more stronger these topics are, it will be easy for you to focus in class 12th when the examinations will come, because this year you will be having board examinations as well. So if you are having good foundation in the class 11 topics, then definitely your class 12th is going to be smoother. So keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this time, because this time will not come back again. So make most out of this time and let's nail JEE examination. See you in the next session. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much. Bye bye. Take care. Happy learning.